Do you ever work with pneumatic actuators? Our Easy Pneumatics Controller is the easiest way to control air-driven motion I have ever seen. The no-code programming interface is so easy, even I can program it, and that's saying a lot. Create sophisticated motion in minutes, not weeks, with Easy Pneumatics Controller. Learn more at teampipeline.us.
Going fast is not always the fastest way to do anything. And if I go fast right now, the whole process is going to take longer.
Hello and welcome to the Being an Engineer podcast. Today we are privileged to be with Callye Keen, who is a return guest here on the Being an Engineer podcast and a dynamic figure in the world of manufacturing and entrepreneurship, known for his deep expertise in product development and his role as a consultant and coach for innovators. Callye is the founder of Red Blue Collective and K-Form, where he has helped design and manufacture hundreds of products, particularly focusing on transitioning from prototype to mass production. Callye is also the host of End Hype and the Startup Defense podcasts, where he explores the intersection of innovation, manufacturing, and defense. And this is episode 2 of our series focused on how to accelerate the speed of engineering. So Callye, welcome to the show, and super excited to talk with you about ways and methods that you have seen engineers accelerate the speed of their projects.
Thanks for having me, Aaron. Yeah, this is a great conversation. Much needed, right? You want to innovate, we want to move fast. So
Absolutely. And man, the first question I have is, before we get into how to speed up engineering, what are some of the steps that slow things down? Where have you seen common bottlenecks?
Well, I'm going to leverage my background as a manufacturer, and I'm going to tell you the number one thing that I see is people designing products that are difficult to manufacture or even difficult for them to prototype. I love a 3D printer. It's a great tool, but it has allowed people to make unmanufacturable geometries, so things that are very difficult to scale. So we'll see products come across my desk where they don't just need DFM, they need to just start from scratch. And it's a big delay.
Absolutely. We were actually talking about this not too long ago. We have a vendor that we use regularly who is so good at machining, and he's so good that at times he won't tell us when we have given him a bad design, and he'll just make it, and we get parts back and everything looks great and parts fit. And for what we do, it's not that big of a problem because we're usually only making one of something. We're not trying to scale things up, and we recognize this. We've talked internally about the fact that, man, is this one shop, are they making us bad designers? Of course, they're not making us anything. We're doing this to ourselves. But the fact that they're so good and they can make almost anything, I think we've actually gotten a little lazy at times and just design things that were easy to design, but maybe not the easiest to manufacture, which when you get into high volumes does become a costly problem.
Well, what you're talking about is how I got into product design, how I got into that engineering piece is because of my background in manufacturing, and then starting with reverse engineering and DFM support, and then stretching out to now we do fairly complex, highly regulated electromechanical products for defense. But what is interesting is I want to flip what you said on its head, and having a great manufacturing partner, just like we have great other engineering partners or great subcontractors, is we make things that require maybe 10 companies to create the final finished good. Having a great partner turns a good designer into a great designer, or a good engineer into an amazing engineer. And we'll get into this a little bit more when we talk about how to be fast. But instead of figuring out how to make something manufacturable, just go watch your manufacturing partner and open that dialogue, and you'll get better really, really, really fast. But also, that's a great way to speed up projects, right? So
Yeah.
kind of good segue into our conversation.
I'm going to touch on one more topic for how projects get slowed down. And I'd love to hear your experience here. We work with some very large companies, global companies, billions of dollars in revenue, huge teams. And I guess there's just no way around the fact that when a company gets that large, there's a lot of bureaucracy, a lot of, I don't know if bloat is the right word, but man, some of these companies move so slowly. We're a small team and we can move super fast because it's easy to communicate within, our team of 15, 20 people. But larger companies, their approvals at every step of the way. And, we don't have this NDA in place. I need to get in touch with legal and get them involved. And it slows things down so much. Have you experienced that with, teams that you've worked with in the past?
Yeah. I work with some of the biggest companies on earth. So whether they're the hyperscalers that we work with or large industry, or the DoD is arguably one of the largest organizations that you can handle, doesn't matter how much you niche down, there's going to be compliance issues. There's going to be lots of people on the team. So we could have a whole episode just on strategies for mitigating that problem. But in general, if someone is coming to you and they're saying, Aaron, you're the expert, you're the engineer, your company is the expert, you're the innovator, you're going to help us innovate, you need to be in the driver's seat of telling them how the project will go versus letting their corporate culture influence you. Because if they knew how to run that project, they wouldn't be hiring you as an innovator and an engineer. They would be doing it internally. The reason they're outsourcing is because they need your speed, your capabilities, your focus. And so when you lay out what that project plan is going to be, you can still have the robust approvals. So you can have design reviews at your different stages. And we break up projects into small stages, which allows us to use a more agile process, but then to fit what a corporate wants to see in a waterfall process where we do concept and then engineering, and then we do EVT and DVT and PVT builds. So there's lots of engagement and checks and paperwork, right? You can sell that paperwork, but we're setting the schedule and we let them know that if that schedule gets increased because they need a month to do an approval, well, that's a scope change because I'm allocating resources for the duration of that project. So if they're eating up 30% of 3 engineers' time and it's a 6-month project and it turns into a 9-month project, I've just had a 50% labor cost overrun. So if they're not hitting those approval deadlines, we need to rescope the duration of the project, and there's going to be a change in the cost associated with that. And we do that early because like right now I'm scheduled out, our team is scheduled out till April. And so if I push a project out because I'm not getting an approval, it will mess up the other 8 projects that we're doing right now. So we work on a lot of things. We work really quickly and we're always working on a lot of things, and people work on multiple projects. So it's a big concern, but it's a really good strategy. Leveraging they can't go back and get more budget and they'll look very bad. So in big companies, they're very risk adverse. And the reason they're going slow is they don't want to look bad for risk purposes, but cost overruns are a risk. And so that will help them like internally, the way their culture works to keep them in line. And then the other big thing is that to make sure there's one point of contact on their side, someone that's actually responsible for decisions. And at most will allow there to be a contracting point of contact and a technical point of contact. On check-in meetings, we won't let them have 10, 20 person meetings. There has to be one person that's responsible, and they have to distribute that information to the rest of their team. Otherwise, you get a lot of cropping up and a lot of wasted time on calls, and somebody waiting to the end, they weren't paying attention. They ask a question and stop everything. And it'll kill a project. It's absolutely, you've got to kill that early in a project. Make sure, okay, Aaron, am I doing this for you? Are you the product owner? Are you the project owner? Are you the program manager? Are you the person that's responsible for making decisions? And to get that in writing and get it really, really early, so that responsibility gets relayed to the rest of their team. And so that way we can lay all of those risks at Aaron's lap instead of spreading it around and like doing a lot of internal finger pointing and projects not moving forward.
One neck to choke, right?
Yeah, one neck to choke. You got it. You can choke my neck. I'm always responsible for our projects, so make that part easy. So one way that I have seen projects get slowed down is when engineers don't ask for help soon enough. This can be a little bit controversial because on one hand, you need to give, especially younger engineers, a chance to learn on their own, to grow that muscle of like figuring out how to figure things out, right? But on the other hand, if you give them too much leeway, they spend a lot of time. I mean, weeks could go by without any real results. So what do you think the balance is there? Should we be trying to satisfy both? And when is it appropriate for especially a younger engineer, but it could be even a more senior engineer that just doesn't know the answer to someone to reach out and ask for help? Yeah, this is a really great question. First, asking for help in an appropriate way is a skill that someone has to develop, and it's not necessarily a skill that's taught in school, right? So to learn how to function on a team and say, okay, well, these other people, they're like walking around resources for me to learn. And so asking isn't me quitting trying to figure it out. It is generally how things should get done. So again, putting that in the right context of that's why you have a team, right? But I understand more broadly what you're saying, and learning how to figure something out or going and reading tech specs, going in and understanding how something works is a skill that you have to develop. So being an autodidact is incredibly important. Being autonomous is very important. We have a made up word that I learned from an army buddy that we use all the time is just, there's this temptation, especially with smart people, to just donk around. They feel like they're learning and they're working, but hours or days are going by and nothing's actually happening. And so if somebody's listening and they want to be successful in any technical field, they need to give themselves tight parameters. Is what's an appropriate amount of time that I'm going to dedicate towards looking for a particular fastener or reading a tech spec on a chip or looking at connectors, because you could spend weeks just looking at connectors, or I could just ask somebody, how does this work? And they could tell me, hey, here's three brands, here's 4 different ways of doing this. And that might narrow my search down significantly. But there is a real temptation, and I think that it masks fear, is I'm going to learn I'm just doing a Google search, and I'm really just afraid of making the wrong decision and goofing around. And you really can only learn something by doing a thing, right? If you read it, you're not learning, you're gathering information, and there's a pretty fast saturation point where gathering information is not really helpful anymore. So
yeah, I like to say that doing is better than learning about doing. I felt like in college, there's a whole lot of learning about doing, and maybe things have changed a little bit, but doing is so much more valuable. And I like how you answered that. It seems like the general, concise summary of what you said there was ask for help soon. In general, I think there are times when, nobody knows the answer. And those are the times where, go off and spend the time doing the R&D to figure it out. But someone knows the answer, just ask and get on with things.
It would be better to spend the time to research so you can ask a better question than to research to try to figure it out.
That's a good answer. I also like your thought about setting parameters for yourself. That's reasonable. I'm going to give myself 2 hours to figure this out. And if I can't, then I'm going to go ask Jim over there because I'm pretty sure he knows how to do this. That's a great balance.
You'll see a recurrent theme in this conversation and how we approach design is, has somebody already done this before? Right. Is there something I can buy and take apart? If I have to buy a $2,000 computer or device and take it apart, but it's going to save me 2 weeks of engineering, it's a lot cheaper to have bought and ruined that product. So is there somebody that already knows how to do what I'm trying to figure out? There's no value in inventing something that somebody's already invented. So most of the time we can go buy something. We could go to Walmart and buy something and take it apart. We can go to Amazon and buy something, or we can go to even Alibaba and buy something and then take it apart and figure out how a mechanism works or how a board was laid out or constructed, or, we can learn all these novel things and then build on what already exists. And that's kind of how I view asking people. Like I'm in a manufacturing company right now. I grew up in manufacturing, but still, like, my brother is a master machinist. I can operate a CNC mill, but if I really wanted to ask questions, I can go down and I can look at how we fixture apart and make small changes, or I can ask them and we can walk through it really quickly, or I could spend all day just like thinking that I know what I'm talking about, Yeah,
right. What are some ways that you have found to fail fast and inexpensively during development?
Yeah, it's kind of a segue. What I was saying is, a lot of the times people push off really critical understanding later and later into the process. So like I said, I grew up drawing in AutoCAD and been using SolidWorks for 20 years, but there's like this obsession in making it perfect on the screen and using SolidWorks like it is the de facto tool, when in reality, we can do things really, really quickly. Like we break down whenever we do a project, it doesn't matter how simple or complex. Can I build this out of something that I can buy and connect it and get a proof of concept really quickly? Like we break it down and say, even if this is a year-long project, what can I do next week? What can I do this month? What can I do this quarter, 6 months, and this year? And so you think like, at any point, what can I do next week to figure out if I'm right or wrong? And so if you break down the formal way of looking at this is design of experiments. Right? So can I create an experiment to prove or disprove a hypothesis that I have about a design really quickly? But in general, what that ends up looking like is folding up a piece of paper, buying a thing and taking it apart. Like how can I hack my way to figuring this out as quickly as possible? And so there's these traditional design tools that if you look at design books from the 50s or the 60s, this was the only way things got done, right? Sketching, modeling, folding paper, taking things apart, looking at everyday objects. That's how design was done for the last 20,000 years up until 30 years ago, right? And so if you're not tapping into those tools, that's how your brain is built. Like that's how the wires of your brain are built. As a creative person, as a technical person, you have these skills that have been developed as we've evolved as humans. And then to circumvent those and say, I'm only going to use this one flavor of technology is at your detriment, right?
That's a really good reminder, that we don't need to CAD up and 3D print every new design that comes across our mind, when it's almost like the default should be, what's already out there? How can we reuse or repurpose that? And then if after some reasonable amount of time, you can't find anything out there, then go into SolidWorks, design something, 3D print it, prototype it. I like the phrase you used. How can we hack our way into a prototype? I remember a while back, we had this project and we wanted to test out a technology that we thought was going to work for this project. To really test it out, we had to buy some air cylinders and a Venturi device to create vacuum. And we didn't want to spend all that time just to find out, no, this technology doesn't really work for what we're trying to do. But we had some tape in a drawer. And for this particular application, the tape kind of was good enough to at least really roughly test out the concept. So we did that. We used tape to hack something together. And lo and behold, it worked well enough that we thought, yeah, I think probably that approach is going to work. So then we ordered the air cylinders and the Venturi and we plugged everything together. And yep, sure enough, this works. So that was a great example to me of like hacking something together. Going back to what you said, what can we do now, right? What can we do now, or what can we do tomorrow? Not a week from now when McMaster parts arrive and we get them all assembled and do some programming to get them all talking to each other. No, what can we do now or tomorrow?
Yeah, it's just a different way of looking at things other than I want to start doing math, right? Or I want to start doing CAD right away.
Yeah, right. Psychological safety is something I think a lot about. I think that we have a really wonderful, uniquely wonderful culture here at Pipeline, and team members feeling psychologically safe is a big, big part of that. I think ideas can easily get slowed or even crushed altogether when people don't feel safe enough in the environment, not physically safe. I think we all feel physically safe more or less in this society, but psychologically safe to share what it is we're actually thinking. I wondered, do you have any stories or examples that you can share where you or, someone else on the team did something to help the engineering team feel safe to speak their minds and how that led to speeding up a project?
Sure. Yeah. And it depends on the client and the engineering team that we're working with, because you think we do a lot of client services. And so their business is going to have a different culture. But I want to open this up more broadly. Is we work with a lot of startups. And so that person might be a founder with an engineer on their team as a CTO. And if that engineer came from a big company, they don't really have failure as part of their culture. They don't have fail fast or innovation as a part of their culture. And they formed this startup to do this new thing, to pursue this idea that they have. And there's a big mindset shift in, we talk about lean manufacturing, or you talk about lean startup, where there's a certain type of failure where we could have mitigated risk and not spent a lot of money or a lot of time. But being wrong isn't a risk. That what we want to shift this is like fail fast. People say like we want to, fail fast, fail often. And I want to change I want to change how we talk about that, is that what we're doing is we're figuring out fast. We're acting as scientists, not artists, right? So as a scientist, we're posing a hypothesis about something, we're running an experiment, and then we're getting information, and then we're refactoring. And so the faster that we can do that OODA loop, right, or that PDCA cycle, the Deming cycle, right, the faster we can get to something that's better. And if we know that is how things get done, so we know about prototyping, right? It's like you make a prototype and then we have to make some adjustments and do that. Every idea is like that. If we think that a prototype is just a complex experiment, a multivariate experiment, we need to understand, what are we trying to figure out, right? Like later in the process for us and going to volume, we're trying to figure out, is this the right piece of equipment or fixturing, or we're solving hypothesis around production, right? Is this the tool set or the documentation that we should be using? But really, really early, we're like, should we use pogo pins or should we use this? Or, we have to create the ideas and then go through this process of figuring it out. So like, if we move away from talking about it as failure and thinking through it as experiments, then we can think of it as a healthy way and build culture around quick experimentation. As long like an experiment is a good way of thinking of it because it's defined, right? I am making a hypothesis. I'm going through a process and then I'm getting an outcome that we can all see. And then I can use that information. I'm not just doing things arbitrarily, and I'm not just like spending forever doing something. I'm doing a very deliberate action. And that gets us out of this, I don't know, what do you say is like, gets us out of this guilt or like fear of being wrong, right?
Yeah. Yeah.
So that's one thing. It's very difficult to break the culture if somebody is in a business that they typically like wouldn't accept failure, so we have to build steps and checks into the process itself where there is not just an assumption, but there's a clear deliverable of failure. Like we're defining like, hey, we're going to do this thing and figure out what doesn't work about it or why this doesn't work. And then I'm going to give you a report on all the ways this thing doesn't work. And they're like, all the ways that it works. I'm like, well, no, because if we could just cobble this together and then I could give you a list of all the reasons it works, like it wouldn't be design then, right? It would be execution. If this is a process of discovery and invention. And so if we knew exactly what to do, we wouldn't be designing something, right? We'd be creating something. So I'm going to do this concept and then we're going to make a list of all the reasons why this doesn't work. And like, that's my deliverable for the concept phase. And that's how we mitigate that issue is that we want to create a list. It really is our ECR list or ECN list, right? And it's really our report of how we're going to scope the next phase, but to be able to phrase it like we want to figure out all the things that could be better or why it doesn't work is a much better way of looking at it. Then, oops, this thing doesn't exactly it's not perfect. Now there's zero reason why it should be perfect or
right. You wouldn't need us if it was perfect the first time.
You wouldn't need us, right? And that's just not how it works. It's not how the process works. And I see this for a lot of people that want to become consultants. This is the issue is that this is why they have a hard time with firm fixed contracts or they are always blowing their time budget because they're like, we're going to try this thing and then we're going to fix it and then it's going to be done. I'm like, well, good luck with that. That's not a very robust process for developing complex products. So
yeah.
One
thought I had about creating psychologically safe environments is as the owner of this business, I am always very cognizant that things I say, even though they shouldn't, carry more weight or can carry more weight than something another team member says. And I want to be very clear that I don't think anything I say should carry more weight than something someone else says. Arguably, it should be the other way around. I am not the best engineer. I've said that before and I'll say it until I go into my grave. I'm very good at certain things, but the highly, highly technical aspects of engineer, I'm not the best at those things. Other people on our team are much better at that than I am. And thank goodness that we have those people here. And so I'm always very cognizant when I say something, that I give team members an easy out to overrule me. And I'll just literally say that. I mean, just yesterday, we were having a discussion. There were 3 or 4 of us in a room talking about, trying to make a decision. Doesn't really matter about what. Trying to make a technical decision on a project. And it was just going around and around. It seemed like we couldn't come to a consensus. And so I just said, let's do A. Let's just do A. And then I thought, I could be wrong about this. And I want to make sure that everyone here feels very comfortable telling me if I'm wrong about this. So I said, let's do A. If anyone here feels like that's the wrong call, please speak up right now and tell me that this is not the right approach. It's completely fine if that's not the right approach, but we need to make a decision. So here's my suggestion. Let's do this. And if I'm wrong, please tell me right now. And, anyway, it worked and we got to move forward. And I think everyone felt safe saying, hey, that's a dumb idea. We can't do it because of this and this and that. So I find that just calling it out like that, hey, this is what I want to do, but I recognize I could be wrong. Please let me know if I am wrong and let's do whatever makes sense, has worked well.
I think to talk about different disciplines and skill sets, skill levels, right? This is what your response makes me think of is you need to figure out where someone is in their skill set. And so if you're giving tasks out, so if I'm saying, hey, you're going to handle this portion of the design, you're going to handle the enclosure, you're going to handle this movement, you're going to handle this drive system here, I need to understand where somebody's skills are and push their training so they're in a zone where you think of standard deviations around their comfort point. So if we get an engineer in and it's clear that they don't have knowledge of manufacturing processes, like, well, I have an unfair advantage. I have a manufacturing facility. I'm going to have them learn manufacturing processes, right? If they don't understand how things go together, we're going to have them work in assembly, because growth is about looking at that standard deviation of where my comfort is, that normal distribution curve, and saying, like, let's do something that you're not quite comfortable doing, but is within the bounds of reason. Whereas if I say, hey, we're not going to give you this extremely difficult project, it's not that you can't do it, but it might be too stressful for you because it's an additional task. You might not be able to do it as well as someone else on the team. You might not be able to do it within a reasonable time budget. So there's lots of other reasons why it's not a good decision as a leader. But making an assessment, we give little mini projects to people and say, like, how would you create this small router, right? How would you create a box for this? What do you think about, this motion system? And then to understand where someone is really important. So if you want to be like a solo consultant and you want to come in, you can get a specialty. You're going to say, hey, I just do design for production manufacturing or DFM, or I do sourcing and approvals. There's lots of places to work that are very profitable, and you can get involved in interesting projects and join interesting teams. But if you are going to run a team, it's important to understand that they aren't you. They don't have your skill set, and that could be way, way better. They could be a genius when it comes to high-speed data connects, right? But they could also be really, really bad when it comes to routing a board. They could be really good at things even inside of sub niches, what I'm saying. And so figuring out what that means for the kinds of projects or products that you want to do, and figuring out how can I learn that about my team really quickly, meet them where they are and give them something for they can grow, but that isn't just constantly giving somebody projects or problems that are going to destroy them.
Yeah. Yeah. It's like that Goldilocks zone, right? You want to push people not too much, not too little, but just in that right Goldilocks zone, given those challenges. Well, that's a good segue into the next question, this idea of some people are good at one thing, other people are good at other things. How do we get them to work together? Before I get there, let me share real quickly with everyone that the Being an Engineer podcast is brought to you by Pipeline Design and Engineering, where we don't design pipelines, but we do help companies develop advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services. Learn more at teampipeline.us. And the podcast is also sponsored by The Wave, an online platform of free tools, education, and community for engineers. Learn more at thewave.engineer. We're speaking with Callye Keen today. So, Callye, going back to what I was saying, cross-functional teams, what are some best practices that you have implemented to ensure smooth collaboration specifically in that cross-functional team environment?
Well, sometimes it's out of your control. I'll tell you that. You do client services. I do client services. So sometimes, portions of that team are actually client side. So they're locked in. That can work really well. A lot of the engineers that I work with day to day are people that I met when they were at a client, and now they have their own thing, or they work for us, which is really cool. But, in general, what I find that is helpful is that I'm very curious about all of the different aspects of engineering. And so I want to develop what I call conversational competence. I do that about products that we're going to develop for someone. I want to be a student of that market, a student of that type of product. Again, we might buy some competitive products that are around that landscape to understand what is acceptable in the market. Like, what's the build quality like? What are the materials like? How are they constructed? How light is it? How big is it? Things like that. But, in general, I want to do that with engineering disciplines. It's like, I want to know enough about it to be able to spec it, have a conversation about it. But I'm not an electrical engineer. I probably will never jump into Altium and start designing a board, but I understand it enough to draw, this is where the connectors need to be. This is what's feasible. I can read the spec sheets. I can have a conversation, right? But I'm not going to hand solder a board and test it. And I'm not going to do any of that, right? But I think that this is really important in a cross-functional team, is there has to be T-shaped people. Like, people have to have a little bit of overlap. They have to have some background in working on multidisciplinary projects. So over time that can develop as a mechanical engineer can work with a manufacturing engineer. That's kind of natural. Work with an electrical engineer, or work with, software or firmware. But the biggest part of this is like, to know a little bit about that discipline, then you'll have a lot more respect for the difficulty of that discipline. I think that goes a long way. Another just an odd point, which it might be unique to K-Form or unique to the way that we do business, is I'm very heavy on collaboration. So in general, we work with other engineering companies because we've developed so many products, or we develop so many products at once. The way that we do that is I act as a systems engineer or program manager, and I do a lot of the mechanical design and all the push to manufacturing, but we work with 3 or 4 other engineering companies, and a couple of them, they only have one client, which is me, right? So I have this hypothesis that really, really great people, they run businesses. That's like, I've met some really great, niche engineers, right? Say I'll pick on electrical engineers. So really great EE. They don't want to run their business. They just want to work in RF. And so they want to be an RF engineer. That's it. That's not a business. So they would be a great employee. But in general, when we get into product design and talk about design engineers, or even industrial designers that are very multidisciplinary, in general, they run their own business and they run their own team. And so if you really want to develop complex products, like highly complex products, most likely you're going to be working in teams of organizations versus teams of people. And so this is a meta skill to understand. But I would say, again, you look for companies that are T-shaped, right? They have something that they're very good at, but they have a little bit more on the side of that problem, and that you want to interface with this really highly talented person. It's because they run a company. They might have 5 or 6 other engineers, like at that small product development firm. So again, this is just from my experience. This is how we do things. we collaborate with clients and we collaborate with other engineering companies. So this is a very important skill to understand how to run multidisciplinary teams. But my opinion is, and my experience, been doing this for a little while, is that people that are really, really awesome, they either run a product company already and you can't hire them, or they run a development company and you can hire that company, but you can't hire them.
I like your term, T-shaped people, right? People with a little bit of overlap. I'm really good with mechanical. I know some electrical. This is not true. I'm terrible with electrical, but the example is I'm good at mechanical. I know a little electrical, and the other guy I'm working with, he's really good at electrical. He knows a little bit of mechanical, and we'll naturally work together because there's enough overlap there, as opposed to truly me, which I know nothing about electrical and couldn't even have a conversation with an electrical engineer because immediately the conversation would go over my head. But I like the idea of the T-shaped people. That's a really good phrase and a way to remember that. How about a tool or a technology that you've seen implemented that has really moved the needle in terms of accelerating the speed of engineering?
And there's so many frequent ones, and I'm sure someone else on the show will talk about 3D printing, right? It's like,
sure.
That's
yeah.
the kind of the common go-to thing. So I do enjoy our cheap 3D printers and making things, but, I grew up through the 2D to 3D CAD kind of transition. I'm almost old enough to remember in the 90s us switching over to CNC, and like that really, you see these big trends go through. People are talking about AI like this too. And there's like, oh, this piece of technology is going to come and it's going to disrupt the whole industry, and there'll be no more engineers, or there'll be no more machinists, or no more manufacturers. It'll all be computers, right? That's what they said in the 90s. There'll be no more machinists. You just walk up to a mill and boop, 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 and you'll get your part because it's going to be all computer controlled. No, the machines just got more complicated. The parts got more complicated. The productivity was increased. Same thing with CAD, right? So 2D CAD to 3D CAD, they're like, oh, this is now one engineer's 10 engineers. And it's like, yeah, but now they just design more complex parts.
Yeah.
And same thing with 3D printing, and now, with generative design and AI. And so I look at these things, and I think that that's all well and good, but really what has pushed us farther forward is just now there's more collaborative digital space. So I could talk about emergent trends with digital thread with engineering, but now just to be able to have all of our files where we can collaborate in one space. I have all of our servers virtualized, or I can go through SolidWorks to Altium and be able to push and pull my EBOM to other tools, and I can have all of this where one of my engineers is in Denmark, right? I have other engineers that are right down the street, others that are in California. We have teams that are in it, just they've never even been to our facility, right? Other teams. And it's like, that has been a game changer. The ability to be able to do that and do that securely.
Distributed teams.
Is to have distributed teams, but to be able to do it for real. And that's still very emergent. It's difficult with a tool like SolidWorks. We use their PDM tool, but even with that, it's fairly difficult, even virtualized, to be able to work on large assemblies or large projects together. But it's there enough where I can be anywhere in the world and I can interact with, we have hundreds and hundreds of products that we support. So like we have, easily, 5 to 10 projects going at a time. So to be able to access that and grant access to that across all of the disciplines is amazing.
Yeah.
Way underrated.
I'm really excited to see what happens with Onshape. Do you know Onshape, the CAD program?
I do know Onshape. Yep. Mm-hmm.
Yeah. So they're, I'd say, still in the up and coming phase. But they enable some of the tools that you talked about, this ability for anyone to jump into CAD wherever they are in the world, as long as they have an internet connection. And not only is the remote access so easy, but collaborative design where multiple people can be in real time working on the same part or the same assembly, and each other's changes show up in real time. And they've got all this branching technology. And I just think it's a really cool platform. We're actually holding one of our PDX events, our Product Development Expo webinars, tomorrow, talking about Onshape. I would love to use it for pipeline, but all of our customers use SolidWorks. And so we're kind of beholden to that and stuck in the dinosaur that is SolidWorks. I shouldn't say that. SolidWorks is a great tool.
I mean, so Onshape was started by the person that started SolidWorks, right?
Yeah.
And the main problem for us with tools like Onshape is unless it becomes
ITAR compliant.
ITAR compliant.
Yeah.
You FedRAMP approved. I can't use it for anything. So same thing with, Fusion is, we've taught lots of people how to operate a CNC mill, and they can use, there's great things about Fusion, but we can't use it. So,
yep. Yeah, you do have some unique challenges when it comes to government or defense related work. Well, let's see. Are there any tools or processes that you have found that do a great job in optimizing communication within teams to support those faster project timelines?
Yeah. I'm always looking for something that's better. We trialed the 3D experience platform because we are SolidWorks based, and then to say, hey, we can do this for our non-ITAR products. But right now we are trying a mix of, depends on the customer, but we're trialing Signal and Slack and even Discord, because Slack has the most integrations, and you look at some of our other tool stacks that we use, like we use Miro for quick diagramming. I use Notion for a lot of our documentation, especially collaborative documentation tools, which are, it's really, really strong. And then I can interconnect a lot of those things. So I can, if I get tricked into using a project where I have to have Jira, I can push a Jira ticket from Notion to Jira to Slack, and it all work together. But in general, I really like Notion because I can use that for all of my PRDs. I can use it for simple project management. I can use it as a research tool, and then I can connect that to my Miro board, or if the person's using Figma, I could use Figma or FigJam for the same thing. But a visual way of creating our block diagrams or explaining something in an easy way, or even just taking snapshots of other products and say, like, hey, do you want this to look like a VW Beetle, or do you want this to look like a Lamborghini? Like, these are two cars, but they're visually distinctive. So like, which one looks cool to you? And creating things like a mood board or other, aesthetic documentation. So.
Tell me a little bit more about Notion. I'm familiar with the platform on a very rudimentary basis, but I've never really used it, dug into it myself. How do you use Notion to enhance communication?
Yeah, because you think in some ways it's like a more enhanced wiki, but you could also do simple databases in it. You can use it as a project management or task tool. But anything that you'd use a wiki for, it's like spinning up a page, right? So the reason that I use that versus Google Docs is that people have a tendency to just start making Google Docs that are completely disconnected from each other. And you're like, oh, it's not in that. It's in this Google document. It's in here. So I want a central repository for each project where even if they are using a Google Doc, at least the link is listed there. So I have one place. And in the past, I would try to make just simple wiki pages or websites where I linked hey, here's where all of your documents are, because they're on these projects, they'll have, here's where we do our project management. Here's where our corporate brand standards are. Here's the tech specs for our product that has to get incorporated in here. Where are all the tech specs for the things that you're putting in? Where are the drawings going to be? Like, where's so you have 80 places that things are, plus somebody on their team just creating Google Doc after Google Doc, and I'm like,
yeah,
I'd rather just go to one place and it's like, here is each step. Here's the design review from each step. Like, here's our research document that has all the information. Here's the PRD. So if you want to change the PRD, it's just right there, like your product's requirement document. So, you can dive pretty deep into the Notion pool and see that it does a ton, but for us, just you think of because you can create all that documentation natively to it and link all the subpages, I can create a single source of truth for anything related to the project. And that's ultra powerful.
That's great to hear. I've actually been shopping around a little bit for a different project management tool. There's some things I really dislike about what we've been using. So I had not even considered Notion as a potential solution for that. So I'll have to look into it.
I will say that it's not a project management tool. It has project management. So you think it's very rudimentary how it works. But for the most part, and this is like a tangent, I think that most teams don't really need heavy project management. That's the thing, is that, that is a overrated industry.
We found that we did a big, kind of a internal study on this a while back. And we have this really robust, kind of heavy isn't quite the right word, but robust and very feature-rich project management tool that we use. And when we really took the time to understand how we were using it, what we learned was that we use it to track time and we use it to track expenses. But the actual tasks, those mostly happen through discussions, in-person discussions or Teams calls, project leads talking with individual contributors, not through a long typed out description in a task that got assigned to someone.
Yeah, we don't do story points or tickets or anything like that. Not even for very large projects. We have a standard template for how all of the phases of our projects work, and there's standard tasks in every one of those phases. Pretty much any project that we do has those standard tasks. So like what that task, the actual execution of that task may differ, bigger or smaller, but like those are common tasks to anything that we would do. And so you can just execute that. This is how long each of these phases are. Here's an extra deliverable to this phase, but all I need, that's all I need. That's it. Like I've found that anything that goes further than that is a tool to create a job for a project manager. And we don't have non-functional managers. We just have leads. So like I'll lead a project, or a contractor that we're working with will lead a project. Even on our shop floor, we don't have supervisors. We just have a lead person that's in that area. And that whole like middle, I found, unless they're very technical and they're working in the project day to day, they don't actually have enough value to be paid. And I'm in Washington DC, so I'm in like the epicenter of like PMPs, and I actually have a project management cert. So I don't want to disparage anybody's job, but I'm like, I need engineering. I don't need Jira tickets issued.
No, I agree. We run things much the same way here. Our project leads are defined as half working in the project and half kind of keeping track of schedule and budget and things like that. But they're actively doing the engineering work as well. Have there been any lessons that you have learned from projects where you attempted to accelerate the speed of that project and it backfired? Anything we can learn from?
Oh man. Any bad lesson that you can learn, I've probably learned it. Yeah, because, very commonly customers or your sales team are going to ask like, hey, the classic for us is, hey, there's XYZ trade show coming up and I want to be able to bring a prototype to that trade show. And you say, okay, well, that's for bench testing, right? It's not a sales demo. It's a prototype. It's a prototype. It's an engineering build prototype. It's to be able to figure out if it works or not. So I can't guarantee that it's going to work right off the bat. And they're like, no, this is a big deal. This is a big deal. Like, let's try to get it done. We'll just try to make it try to make it nice. And so you bust your butt, polish it up, spend all the time to try to get this thing. Hey, it works. It's all great. And then the customer gets it and says, man, this is a piece of junk, right? This thing barely works. It looks like you made this in a hurry. It's all glued together, or it's all, there's glue here, or it looks like you tack welded this, or, whatever complaints. And you're like, you can learn your lesson in this is that if it's not a part of the plan, you have to just say, no, I'm not going to do that. Right. So there's a lot of this like false acceleration. And then you find out that, well, there's a trade show in 2 weeks. And that's the big one. And now you can't do that one because they traveled with this other prototype and now they won't give it back to you. And you need this to continue engineering. And now you don't have it to work from. And so now you've got to build another one. And so now they're going to miss the big trade show. And like, you just get into this endless thing is that you need to understand the process and you need to be the process owner. So whatever types of things that you're developing, you build that skill and discipline. And I have to remind people, and it's hard to say this without sounding like a pompous ass, but it's like I've developed hundreds of products, right? We've built companies from 1 or 2 people up to $100 million businesses. We've worked with them through acquisition. Like, you're coming to us because we're experts at doing this thing. Okay. This isn't a good idea for this reason. And we're not going to do it because these are the problems that it's going to cause. And so when someone wants to go faster, sometimes there is a way to go faster, right? You can pay expedite fees for a part or airship something versus ground ship something. You can shorten a sprint, right? But adding more people to a project will not help, especially if the project is halfway through. Working all night creates a bad precedent, and doesn't really create great outcomes. Changing or like removing the correct tests or documentation will just shift a problem or cause it so you have to redo all of the work later. So in general, the fastest thing to do is have a standard process, work that process and refine that process. Like that is your product, right? As an engineer or a leader or a company, your product is the process. And so you're working and tinkering on that. And then when somebody wants to mess with your product, you have to ask yourself, do they know more about your product than you do? And I hope for the love of God that they don't, because then you're in a lot of trouble. And so in general, going fast is not always the fastest way to do anything. And so reminding people, hey, I know what I'm doing. And if I go fast right now, the whole process is going to take longer.
Yeah. I think it's our engineering manager who says, when you need to go fast, slow down.
Yeah.
Well, let's bring this all to a close here. Final question. Obviously, there are many, many factors that ultimately contribute to one's ability, a team's ability to accelerate the speed of engineering, if such a thing even is possible. If you had to choose the most important, the factor that had the most profound effect at speeding up engineering projects, or at a minimum, not slowing them down unnecessarily, what would that be?
Easy. There isn't even a close second, is go make things. You have to actually make stuff. If you're an engineer, you got into this because you wanted to make race cars, or you wanted to make drones. You wanted to make something cool. And all the best engineers that I've ever met, whether they were engineers in Formula One, they were making things for space, they made computers, they made robots, every single one of them, they made a thing. So I don't know any good mechatronics engineers that didn't make robots, right? I don't know any good mechanical engineers that didn't work in manufacturing or build their own products. I don't know those people. I have met lots of bad engineers who have never done any of those things. But if you want to go fast, you want to make money, you want to work on cool projects, you want to work with skilled, competent people that will elevate your career or knowledge to the next level, go make stuff. Go find people that are making stuff and make things with them. If you're really young in your career, think about going and working for a manufacturer as a manufacturing engineer, or as a mechanical engineer, or as a systems engineer. Some other discipline where you get to be adjacent to people that are making things and participate in that process. You will be a 10x engineer if you know the breadth of the process, you know the execution of it. That's it. There's not even a close second to how to be better as an engineer.
I love it. Great answer. Great answer. Well, Callye, what a delight this has been. Thank you again for being on the show and sharing so much of your experience and insight into the topic of speeding up engineering projects. How can people get a hold of you?
Well, I've really pulled back a lot from social media. I'll tell you that, but I am on LinkedIn all the time. So it's probably the easiest way to find me. I have a very unique name. So if you search, you'll see I put out a lot of content. I previously had a podcast called End Hype that you mentioned. It became in the 0.5% of all podcasts in the world. This is one of the top product podcasts that was there at the time. Right now, my current podcast is about defense startups and around the innovation ecosystem that we see kind of evolving in that space. Is called the Startup Defense. That's a easy way to look at some of my current content. We've had some unbelievable guests on there. Literally some of the most successful, or I think people that are making some of the most interesting products in the world on the show. And so that's been a real honor to do that. But yeah, in general, like you can check out kform.com, see what we're doing, or you can just, hit me up on LinkedIn. So
terrific. Callye, thank you so much.
Yeah, thank you.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.